to apply the formulas that we saw to calculating the percentage change in a bond's price given its duration and convexity. And here is the first question that we're going to be doing. Now, before you pause the video and start to solve it, there are a few things I want to help you out with because it's a fairly long question and I don't want you to make a mistake in the areas which we have covered in different videos. Because if you're making a mistake in that area and you're not being able to apply the concept to this particular area which is related to convexity, then it defeats the purpose of solving this question together. So what I'm going to do is, number one, I'm making available the formulas that you need to know so that instead of focusing on trying to recall the formula and making a mistake in that, what I want you to focus on is applying these formulas. That's point number one. Point number two, before you can get to this second question, you have to be able to tackle the first question. And I know that you're most likely going to be able to do it, but I don't want to take any chances. So I'm just going to help you out with the first part so that you are in a better position to handle the second and the third and the fourth part. So let me just help you out a little bit for the first part, just to make sure that you don't make a mistake with that. And then obviously because if you make a mistake in the first part, then your second and third parts just get spoiled, right? And what I want you to really focus on is the second and third. So I'm going to help you out with the first. Okay, so what's happening in this bond is that it's maturing on 4th April 2029. And currently you're in 83 days from the 4th of April. So what you're basically saying is that if it matures on the 4th April 2029, and if you take it from the beginning, which was, let's say, 4th April 2014, well, then that's 15 years, right? From 14 to 29, that's 15 years. So you can make your n is equal to 15. You can calculate your FV, assume it's 100. PMT, you can assume 6.5% of FV, which will give you 6.5. I by Y, they have told you, is 6.74 right now. And you can compute the PV. Now, this PV obviously is assuming that you're on the 4th of April 2014, but you're not. You're 83 days ahead of that, right? So whatever PV you get, you need to multiply it by 1.0674 because that's the annual yield to the power of 83 over 360 because it is using the 360 year. And then you will get your point number one. So that is something that I've just helped you out with. What I want you to focus on is calculate PV if the interest rate was going down by 1 basis point, if the interest rate was going up by 1 basis point, and calculate, use that PV minus and PV plus to calculate the approximate mod D and the approximate convexity. Then plug that in to this formula and calculate the percentage change from 100 basis point change. Then what you have to do is then again use that first question method of taking n as 15 and FV as 100 and PMT as 6.5. However, IYY will become 7.74 instead of 6.74. And then calculate your PV and then again load it up with interest by multiplying it with 1.0774 this time instead of 674, and that of course will be 83 to the power of 83 over 360, and calculate the new price and then compare that new price to what was the price that you got in the first part and see what was the percentage change, and compare that percentage change to what you have estimated based on this formula. Now I know I've just given you a lot of information. So what you can do is now pause the video, look at the timestamp, right? And you can watch this part before the video from this point, right? So you can just hear this part again, but don't go forward until you have tried to solve this yourself, right? So try to solve it yourself and then see the solution. So please pause the video. You can watch the earlier part again if you want, but don't go forward. Solve the question yourself and then see the solution, right? So please pause the video and solve the question and then see the solution. Right, so hopefully you were able to do the first part easily, right? I helped you out with that quite a lot. You just have to calculate the PV based on 15 years, PMT of 6.5, I by Y of 6.74, FV of 100, and then you load it up for the 83 days of interest and you get 99.2592. Then what you do is you calculate your PV minus and your PV plus, right? And then you take that and you plug it into these formulas and you calculate your approximate modified duration and your PV plus and your PV minus after loading them up with the interest, and then you use those to calculate your approximate mod D and approximate convexity. Now if your calculation was wrong, maybe because you didn't do the second step, right? So you can now again go back to the question using these two, approximate modified duration and approximate convexity. Now try to do question 3 again, where you have to plug in the correct approximate modified duration and the convexity and try to calculate the percentage change estimated. Right, so hopefully you were able to do that, and it comes to 8.1%, where this part, which is the duration estimate, is coming to minus 9.1075, and obviously the duration will always estimate that it is falling more, right? But the convexity will stop it from falling. So you actually add that 1.00746. If it was going up, well, we would still add the convexity, because convexity gets added in both situations. Even if it is going up, it goes up more than duration would say. And even if it is coming down, it doesn't go down that much because convexity is still added. Convexity is always added, right? It's always a positive number. And that is because it is squared. So it is, let me just go back and show you why this is a positive number. Because this difference will always be positive, right? Because one of them is more. And the higher price is always going to be more than the lower price, right? The higher price is always going to be rising more than the lower price. So that's always positive. And also the yield is being squared. So even if the yield is going down, it becomes a positive number. So the convexity adjustment is always a positive number, right? And then you get your estimate, which is 8.1. Now compare it to what is the number you get if you manually use your formula to do it. So previously what we had done is we had used a yield of 6.74, right? So instead of using a yield of 6.74, if you use a yield of 7.74, right? And the same way over here, if you use 7.74, what will happen is that the present value you will get will be 89.215, right? And then if you load it up with the interest, then what you get is 90.7623. And if you compare 90.7623 to your original one, which was 99 0.2592, this one, right, this original one, then you see that that is a change of 8.5%. It has gone down by 8.5%. But if you remember, the adjusted amount, that estimated amount that you were calculating was 8.1, which was over here. So this 8.1 is the one that you were calculating earlier. Right. So that is your first question. Now I know you might be feeling a little bit lost. So we have another question for you. And we've got, well, this actually has two parts because it has two bonds. So you've got your 25-year 5%, and then you've got your 75-year 5%. And what you want to do is, assuming a 5% basis point change, please calculate the mod D and approximate modified duration and approximate convexity for each of these. So pause the video, please try to calculate it, and then I will show you the answer. Right, so hopefully you were able to calculate the PV plus and the PV minus for both of those bonds, and you were able to calculate the approximate mod D and the approximate convexity for each of those. So that is it for applying these formulas. In the next one, we're going to look at how we add duration and convexity for a portfolio of bonds. So see you in the next video.